In the previous video, we've learned how to make predictions using artificial neural networks. We have found that it requires time and trial and error to find the appropriate neural network topology and parameters. Today, we will see how to use Orange to compare different data mining techniques, to adjust their parameters, and evaluate their performance. Let's start to set up the workflow to classify our Titanic dataset. Let's load it by using a file widget from the data panel. Select the Titanic clean dataset. Now we will add a Select Columns widget from the Transform panel. As usual, let's use only the sex, age, and P class features and the usual survived as a class. Today, we don't need the data sampler, as the Test and Score widget includes the sampling selection. So, let's directly add the Test and Score widget from the Evaluate panel to the canvas. This widget needs in input one data source and at least one model to evaluate. Let's start by connecting it to the Select Columns widget. Now we are ready to set up all the models we want to test. Our first model will be a decision tree. Let's add the decision tree widget from the model panel to the canvas. Connect the output channel of the decision tree to the input side of the Test and Score widget. We don't need any input to the model, as Test and Score will take care of feeding it with the data. Next, we will create several artificial neural networks with different topologies. Let's add a neural network widget from the model panel to the canvas. Double-click on it. Set the number of neurons in the hid layer to 50. Make sure the regularization is set to 0. Rename it to Neural Network 50. This step is needed to identify it when evaluating the performance. Now you can connect it to the input of the Test and Score widget. Let's repeat the step by first adding another neural network widget. Set the number of neurons to 256 and rename it to Neural Network 256. Connect it to the input of the Test and Score. Now, last one. Add a neural network widget. This time we will set 2 hidden layers. Change the number of neurons to 256, 256. Rename it to Neural Network 256, 256. Connect it to the input of the Test and Score. And now we are ready to test all our models at once. Double-click on the Test and Score. On the left side, you will find the data sampling strategy we want to use. It includes, among the others, the cross-validation with the ability to specify the number of faults, random sampling with the training set size representing the splitting point between training and test data, together with the number of times we ask to repeat the procedure of training testing. Other options include to test on trained data, is not suggested, or test on test data if provided from a different dataset or through specific preprocessing. To be consistent with the tests in previous videos, let's start by using random sampling with 10 repetitions and splitting at 70%. Keep the stratified sampling flag ticked. This helps to avoid some biases in training, as it selects 70% of the data from each survived class. Once you click on a new sampling method, you will see a progress bar appearing in the lower right. All our algorithms are being trained and tested again. It may take a while. Once finished, we can see the performances of the various models. In this case, the training was a little bit different. It repeated the training multiple times, effectively augmenting the quantity of data our algorithms have seen. As you can see from the table on the top right, we have similar situation to what we have seen using the prediction widget. The best performing neural network is the one with only one layer of 256 neurons, and it outperforms in terms of precision the other networks and the decision tree. Now, let's see what happens if we use the cross-validation sampling technique. Select it and keep the standard values of 5 folds and the stratified sampling. After recomputing the models, we can see that this sampling technique was beneficial for the decision tree to outperform the various neural networks. Maybe now the data is not enough for our neural networks. Let's add in the Select Columns widget the FAIR and embarked features to the feature list. Let's go back to the Test and Score widget. After retraining, we can see that the neural networks got better results. This was especially helpful for the biggest neural network that now outperforms in terms of precision the other networks and the decision tree. On the other hand, as we experienced in the decision tree videos, with additional features the performance of the decision tree approach decreased. To conclude today's workflow, we will add a confusion matrix from the Evaluate panel to check the classification errors. Connect it to the Test and Score and then double-click on it. On the left side, we have the various learners. Once you click on each of them, the confusion matrix will change accordingly. Here, you can evaluate which classification result match more your needs. For example, let's compare the two deeper neural networks. The biggest neural network did less errors in total, 141 errors versus 149. But the misclassification distribution in the pink cells is quite different from the neural network 256 model. That's all for today. In the next video, we will look at different tasks in data mining that include unsupervised learning. Ciao!